Azure Storage account contains all of your Azure Storage data objects, blobs, files, queues, tables, and disks. The storage account provides a unique namespace for your Azure Storage data that is accessible from anywhere in the world over HTTP or HTTPS. Data in your Azure Storage account is durable, highly available, secure, and massively scalable. In this video, we will be covering different types of storage accounts, what is blob storage, how security is implemented in storage, how to manage storage, accessing blob and queues using AAD, configuring Azure Storage firewalls and virtual networks. In the end, we will also share details about our free Azure Solution Architect Masterclass, which will not only help you understand basics, but it will also give you an idea of the learning path to follow. It would be helpful, especially when you're preparing for Azure Solution Architect certification, which requires you to clear 2 exams. That are Microsoft Azure Architect Technologies AZ303 and Microsoft Azure Architect Design, that's AZ304. For the certification exam, you should have an understanding of Azure Storage accounts. Welcome to another episode of Azure video series from K21 Academy, where we take you from complete beginner, covering configuring infrastructure, authentication and securing data solution for the cloud and Azure Storage, to all the way identity and security, business continuity strategy, deployment, migration, integration and infrastructure strategy, including how to prepare for the AZ303 and 304 certification exam. We have taken a clip from one of our certification training program on Microsoft Azure Architect Technologies, that's AZ303, and in this clip, our instructor will talk about Azure Storage accounts. So, this is a clip taken from a module on implementing storage accounts. Let's hear from our expert trainer on the same.
We will talk about blob storage, storage security, and Azure Storage Firewall. To talk about some of the objectives, we will talk about different types of storage account, what is blob storage, then how security is implemented in storage, how can you manage storage, what are the tools available for that, then accessing blobs and queues using AAD, configure storage firewalls and virtual network. So let's start with storage accounts. So Azure Storage is Microsoft's cloud storage solution for modern data storage scenarios. Azure Storage offers a massively scalable object store for data objects, a file system service for the cloud, a messaging store for reliable messaging, and a NoSQL store. So the massively scalable object store is called Azure Containers or Azure Blobs. The file shares are called Azure Files. Messaging store is called Azure Queues. A NoSQL store is called Azure Tables. And there are different types of storage account. There is a GPv1 and GPv2, that's general purpose v1 and v2. This includes a file, blob, queue, table and disk. And then there is file storage accounts. Only in those kind of accounts you can create only files. Then we have blob storage accounts, also known as blob. It can take only blobs and append blobs only. So to talk about some of the key benefits of Azure Storage, or what Azure Storage is, it's durable and highly available. So redundancy ensures that your data is safe in the event of a transient hardware failure. You can also opt to replicate data across data centers or across geographical regions for additional protection from local or natural disasters. Data replicated in this way remains highly available in the event of an unexpected outage. Secondly, secure. All data written to Azure Storage is encrypted by the service. So we already talked about SSE, that's a storage encryption service. Azure Storage provides you with the fine-grained control over who has access to your data. Then scalable. Azure Storage is designed to be massively scalable to meet the data storage and performance needs of today's applications. It's completely managed, so Azure manages the infrastructure, updates and critical issues for you. Accessible. Data in Azure Storage is accessible from anywhere in the world over HTTP or HTTPS. Microsoft provides SDKs for Azure Storage in a variety of languages like .NET, Java, Node.js, Python, PHP, Ruby, then Go and others. As well as it has a mature REST API endpoints as well. So Azure Storage supports scripting in Azure PowerShell or Azure CLI. And Azure Portal and Azure Storage Explorer offers easy visual solutions for working with your data. With Azure Storage, we can use it to store files, messages, tables, and other information. You can use Azure Storage or Install, for example, as a file share, but it is often used by developers to store for working data. Such stores can be used by websites, mobile applications, desktop applications, and many other types of custom solutions. Azure Storage is also used by IaaS virtual machines, PaaS cloud services, etc. You can generally think of Azure Storage in three categories. Storage for virtual machines. This includes disk and files. Disk are persistent block storage for virtual machines. Files are fully managed file shares in the cloud. Unstructured data. This includes blobs and data lake store. Blobs are highly scalable or REST-based cloud object store. Data lake store is a Hadoop distributed file system, that's HDFS as a service. Then structured data, this includes tables, Cosmos DB, and Azure SQL DB. Tables are a key value, auto-scaling, NoSQL store. Cosmos DB is a globally distributed database service, and Azure SQL DB is a fully managed database as a service built on SQL. General purpose storage accounts have two tiers. One is standard, another one is premium. Standard storage is backed up by magnetic drives, those are HDDs, and provide lowest cost per GB. They are best for applications that require bulk storage where data is accessed infrequently, because the read-write speeds are very less compared to premium. Premium storage accounts are backed by SSDs, that's solid-state drives, and offer low latency performance. So they can be used only with Azure virtual machines for best IO intensive applications like databases. One thing to note here is it is not possible to convert a standard storage account to a premium storage account or vice versa. You must create a new storage account with the desired type and copy the data if applicable. If you have anything already in the standard tier, you have to create a new premium one and migrate, or vice versa. Alright, so let's see what are the storage services. Azure Blob Storage, which is also Azure Containers. Then we have Azure Files, Azure Queues, and Azure Tables. So Azure Blob Storage is Microsoft's object storage solution in the cloud. Blob storage is optimized for storing massive amount of unstructured data such as text or binary data. Blob storage is ideal for serving images or documents directly into your browser, storing files for distributed access, streaming video and audio, storing data for backup and restore, disaster recovery and archiving, storing data for analysis by an on-premise or Azure-based service. Objects in blob storage can be accessed from anywhere over HTTP or HTTPS. Users or client applications can access blobs via URLs, the Azure REST API, PowerShell CLI, or an Azure Storage client library. So the client libraries are available in multiple languages like we saw earlier: .NET, Java, Node.js, Python, PHP, Ruby, etc. Secondly, we have Azure Files. Azure Files enables you to set up highly available network file shares that can be accessed by using SMB, that's a Server Message Block Protocol. That means that multiple VMs can share the same files with both read and write access. You can also read files using REST interface or with the storage client libraries. One thing that distinguishes Azure Files from files on a corporate file share is that you can access the files from anywhere in the world using the URL that points to the file, and it includes a shared access signature or SAS token. So you can generate SAS tokens. They allow specific access to a private asset for a specific period of time. So when it comes to securing storage accounts, we will talk about what is SAS key, how they can be used, how it is generated and all. For time being, just understand that files can be accessed anywhere using the URL appended with the SAS token. So files can be used for many common scenarios. For example, many on-premise applications use file shares. So this feature make it easier to migrate those applications to Azure. If you mount the file share to the same drive letter that the on-premise application uses, the part of your application that access the file share should work with minimal, if any, changes. Then configuration files can be stored on a file share and accessed from multiple VMs. Tools and utilities used by multiple developers in a group can be stored in a file share, ensuring that everybody can find them and that they can use the same version. Then diagnostics logs, metrics, crash dumps are just 3 examples of data that can be written to a file share and processed or analyzed later. At this time, Active Directory based authentication and access control list are not supported, but they will be supported sometime in the future. The storage account credentials are used to provide authentication for access to the file share. So just like we saw, the SAS token is used to provide authentication. This means that anybody with the shared mount will have full read-write access to the share. Alright, so to talk about queue storage, the queue service is used to store and retrieve messages. Queue messages can be up to 64 KB in size, and a queue can contain millions of messages. Queues are generally used to store a list of messages and can be processed asynchronously. For example, say you want your customers to be able to upload pictures and you want to create thumbnails of each picture. You could have your customer wait for you to create the thumbnails while uploading the images. An alternate would be to use a queue. When the customer finishes his download, write a message to the queue. They then have an Azure function retrieve the message from the queue, create the thumbnail. So each part of this processing can be scaled separately, giving you more control when tuning it for your usage. That's one use case scenario of queue storage. Table storage. Azure Table Storage is now part of Azure Cosmos DB. In addition to the existing table storage service, there is a new Cosmos DB table API that provides throughput optimized tables. It also provides global distribution and automatic secondary indexes. So to learn more about and try the new premium experience, you can check out the Azure Cosmos DB table API. So let's talk about the storage account types. So blob storage, GPv1, GPv2, blob storage, and file storage. So these are the different account types, and you can see what are the supported services, what are the supported tiers, and what are the replication offerings. So LRS is locally redundant storage, GRS is geo-redundant storage, RAGRS is read access geo-redundant storage. Then there is a ZGRS, that's which is zone geo-redundant storage, and you have a read access for that. Sometimes it is written as a GCRS, which is geo-zone redundant storage. So you can use both of them. That's fine. I think we have a session on a particular slide on how LRS is different from all these, and we will talk about all these redundancy methods. So to talk about GPv1 accounts, those are legacy type for blobs, files, queues, and table. So use GPv2 accounts whenever it's possible. When it comes to GPv2 account, which is also called storage v2, basic storage account type for blobs, files, queues, and tables, recommended for most of the scenarios using Azure Storage. Blob storage accounts, it's a blob-only storage account with premium performance characteristics, recommended for scenarios with high transaction rates, using smaller objects, or requiring constantly low latency storage. File storage accounts, these are premium performance and can only use file storage. Then we have blob storage accounts, blob only storage accounts. So they use they can be only used for blob, that's blob and append blobs only, and it doesn't have a premium tier. So you have to there will be latency, and it's not meant for high IO intensive applications. The recommendation is use GPv2 whenever possible instead of blob storage. And all of these storage accounts are encrypted using SSE, storage service encryption, that we studied earlier. Alright, so now we will have a walkthrough of how an Azure storage account is configured to allow for replication and high availability of data. So as previously mentioned, Azure storage accounts are used to house data objects such as files, blobs, tables, and disks for virtual machines. The data that you store in a storage account can be accessed anywhere from any location globally via HTTP or HTTPS, and is highly available and secure. So in order to make it highly available, we have to talk about the data redundancy. So as I said, data in Azure is replicated to ensure that it is always available, even if a data center or a region becomes inaccessible or a specific piece of hardware fails. So we have 4 replication options. There are others which are in preview, like GZRS, RAGCRS. So these are the main ones. If you can understand these, then you will be easily able to understand the others as well. LRS, that's locally redundant storage. ZRS, that's zone redundant storage. GRS, geographically redundant storage. RAGRS, read access geo-redundant storage. So let's take a closer look at each of these and understand what it is. So to start with, LRS. So LRS replicates data and stores 3 copies of data across fault domains or racks of hardware within a single data center facility in one region. So data is replicated so that if there is a hardware fault or maintenance work, your data is still available and accessible from another rack. LRS protects your data from hardware failures but are not protected if there is a data center outage. For example, if Array 1 in UK South suffers hardware failure, your data is still available on Array 2. If the entire data center suffers a failure, you are most likely to lose your data. LRS is the least expensive replication option available. It also offers least durability because you can potentially lose all your data if a data center outage occurs. I mean, this again depends upon the severity of the outage. It's not like if something happens on the data center, your data is lost, but it depends upon the severity. How severely this is affecting the storage, then that will cause some issues. The next one is zone redundant storage, or ZRS. So zone redundant storage replicates your data across 3 storage clusters in a region. Each cluster is physically separated from other 2, which means that each cluster is supplied with separate utilities such as power or network. So your data is in different availability zones. If there is an outage in a data center, you can still access your data from another availability zone in that region. Data is normally replicated to 2 or 3 availability zones, depending upon the number of availability zones that you have in the region. An availability zone is a physical location that is made up of 1 or more data centers in the region. So you might know this information by now because we have discussed this so many times. So there are typically 2 or 3 ACs per region, where each AC is independent of other ACs in the region. CRS offers it's 99.999, that's 12 nines after that % durability of data. So you know how big is that value. That's like almost 100%. Even 99.99 is considered as, we consider it as 100%. So think about 99.12 nines after that in the decimals. So however, CRS might not protect you from a regional outage. So this is one region, your replicas are stored in different availability zone. What if the entire region goes down? So if there is a region failure, that means all of your AZs are affected. To migrate data from to CRS from either LRS or GRS requires some planning and manual migration. So if you are migrating from, let's say you were an LRS and your business application requires something at ZRS level or GRS level. So this requires planning, and you have to use some tools like AZ Copy. So we will talk about AZ Copy at the very end of the session, where we have a demonstration on how to use AZ Copy. So that's one tool you can use to do that. Alright, so the next thing that we have is GRS. As the name says, it's a geographically redundant or geo-redundant storage, which provides multiple levels of replication. Your data is replicated 3 times within the primary region, and then a set is replicated to the secondary region. So GRS provides the highest level of durability because you finish with 6 copies of your data. Such durability means that even if there is a data center failure or regional issues in the primary region, your data is always available. If the primary region fails, Azure Storage is still available in the secondary region. The secondary region is automatically paired to the primary region based on the primary region that you selected. This pairing configuration cannot be changed. Keep in mind that your data in the secondary region is inaccessible until the primary region has failed across to the secondary region. At this point, the secondary region becomes the primary and your data becomes accessible. Now we have RAGRS. So geo-redundant storage provides 99.15 nines. I can't count them. Anyways, that's increase more than ZRS. I think it's 15 nines. I'll count that and confirm. % durability, because it replicates the data and objects to a secondary region. So when a failover starts, DNS entries that point to the primary region are updated to the secondary region. Microsoft currently controls the DNS failover operations. When you use RAGRS, you need to ensure that the application knows which endpoint it is interacting with. The secondary region has a secondary appended to the name of the endpoint. RAGRS is ideal for applications which require high availability. A new feature is currently in the preview that allow you to start a failover between primary and secondary regions from Azure Portal, PowerShell or CLI. When the primary endpoint becomes unavailable, you can failover to the secondary endpoint. After the failover and the DNS endpoints updates are complete, the storage will be set back to LRS. You are responsible for reverting the replication settings from LRS to RAGRS or GRS after the primary region is available again. Alright, so we have LRS here, we have ZRS here, then we have GRS, RAGRS. Okay, so LRS, let's talk about data copies in each of this. LRS has 3 copies. ZRS has 3 copies in 3 availability zones. GRS has 3 copies within the local region and 3 copies in the secondary region. That makes 6. RAGRS also has 6 copies. To talk about what is it? So this one replicates in a single DC. So it's in a single data center across multiple zones, which are AZs in a region. So this is in a region. So this stores the data in a local DC, which is the primary, and then stores 3 more copies in another region, in a secondary data center. So this one is same as GRS, but offers read access in the secondary region. This one doesn't give the read access in the secondary region. RAGRS gives the read access in the secondary region. Secondary region. So let me make it smaller. Now, use cases. Use cases, LRS ensures that your data is highly available, and it's highly available. Compliance is another thing that some people think about, because I don't have to worry about storing my data in another region, or so you can keep it local. Keep it local. Then this provides a higher durability compared to LRS, higher durability, and still one region, so your data residency and compliance policies are still in place. This need to ensure that your data is always available. So if primary goes down, your secondary should come up. So in the case of RAGRs, where your applications can request data read from other regions, but also ensure that the data read operations are available even if the primary is down. So here the read operation is not available, your data is just secure. That's all. Your data is available. You can always get the data when if it's down. But in the case of RAGRs, you can read the data, and you can, if primary is not available, you can use it from the secondary region. Right. Then accessing storage. So every object that you store in Azure Storage has a unique URL address. The storage account name forms the subdomain of that address. The combination of subdomain and a domain name which is specific to each service forms an endpoint for your storage account. For example, let's say my storage account name is my storage account. Then the default endpoints are the container service, or the blob will be https://mystorageaccount.blob.core.windows.net. Similarly, if it's a table, the same storage account name .table.core.windows.net, queue.core.windows.net, file.core.windows.net. So the URL for accessing an object in a storage account is built into by appending the object location in the storage account. For example, to access my blob in my container, we will use something like mystorageaccount.blob.core.windows.net / my container / my blob is a direct path to that file. Then configuring a custom domain, you can configure a custom domain for accessing blob data in your Azure Storage account. As mentioned previously, the default endpoint for Azure Blob Storage is storage account name.blob.core.windows.net. You can also use a web endpoint that is generated as part of the static website feature. If you map a custom domain and a subdomain such as www.condaso.com to the blob or web endpoint for your storage account, you can use that domain to access blob data in your storage account. There are two ways to configure this service: direct CNAME mapping and an intermediary domain. So direct CNAME mapping, for example, to enable a custom domain for blobs.condaso.com, the subdomain to an Azure Storage account, create a CNAME record that points from blob.condaso.com to Azure Storage account. So let's move this to side. So if I have a CNAME record that says blobs.mydomain.com, so I can have the CNAME pointing to my storage account, like my storage account name is my domain blobs.blob.core.windows.net. So what happens is, let's say I have a file which is in the container videos, and it is m1.mp4. So if I want to download that, since the CNAME is here, if I type this, the DNS resolution will happen to this one. So technically I can just blobs.mydomain.com/videos/1.mp4 will let me download the file which is in my domain blobs core.windows.net/videos/1.mp4. So it is easy to easy to use custom domain. So what happens is this is my storage account name, this is my storage account name, this is the service. So if it was something else like a file, I would have changed this to file. So that's how you can do a CNAME mapping. There's a second method which is intermediary mapping with AskVerify. So mapping a domain that is already in use with Azure may result in minor downtime as a domain is updated. If you have an application with an SLA, by using the domain you can avoid the downtime using the second option, the AskVerify subdomain. So by prepending AskVerify to your own subdomain, you permit Azure to recognize your custom domain without modifying the DNS records for the domain. After you modify the DNS records for the domain, it will be mapped to the blob endpoint with no downtime. So to give you an example, so the CNAME record will be again AskVerify.blobs.contoso.com, and the target to that would be AskVerify contoso blobs .blob.car.windows.net, and then I'll map blobs.contoso.net blobs dot the same thing. So instead of directly using the CNAME, you can prepend this AskVerify to avoid any modification of DNS records. Perfect. The step necessary to restrict network access to Azure services varies across services. For accessing a storage account, you would use a firewall and virtual networks blade to add the virtual networks that will have access. Notice you can also configure allow access to one or more public IP ranges here. So firewalls and virtual networks allows for restricting access to the storage accounts from specific subnets on virtual networks. Subnets and virtual network must exist in the same Azure region or region pair as the storage account. So it is important to test and ensure that the service endpoint is limiting access as expected. So I think we have a demonstration on how this is done. Yep, that's right. So we will create a storage account. We will upload the file and we will create a secure file endpoint. All right, let's jump back to Azure copy and see how this is done. Alright, so in this demonstration, we'll create a storage account, upload a file, and secure the file endpoint. Alright, so for that, first we need to create a storage account. We can just type storage accounts here. So I'll create a storage account now. So the name for the storage account should be unique because the endpoint will come with, as you know, it's like .blob.windows.co.net, right? So it should be unique. If a customer or a person has already created that, you cannot have it again. So let's say if I type something like storage Azure, that should have been already taken by someone else. So come up with a unique name. So easy 300 demo storage. See, that's also already taken. So I'll just add my name to that. Yeah, that's available. Alright, so I'll just go with the standard storage and V2. I don't want any redundancy. I'll just keep it as LRS. So as of now, I'll just enable for everything. I'll make it public so that I can show you how to access the file. Okay, create. Alright, so the source is here. I'll click on go to resource. So now we have option to create containers, files, tables, and queues. Don't get confused with the containers in AKS or container instances. This is just the container here is just like a folder. So if I click on containers, I'll be asked to create a container. So I'll say files, any name, you can give any name. The public access I have to, I can go with the private, so that means nobody will have access. Blob, that is access to the blob only. Container means access to the container and the blobs inside that. So I'll keep it as container. Go inside the files. So that was just a folder. So here is how you can upload the files to the storage account. Alright, so if I click on upload right now, it will come up with a side panel where you can select the folders just like you do it in Google Drive or OneDrive. So let me go to downloads, pick some random files. Okay, so I'll select this file, open, upload. So the file has been uploaded here, and if I click on this file, it will come up with a URL. So I'll just copy this one. So here is how it looks. This is the storage account name. This is a blob.car.windows.net. Files is the container name. This is the file name. So if I hit enter, that file will be downloaded. Yep, there you go. That's what we did. Now we will do another test. So as of now, anybody who has the link can access my file. So now what we're going to do right now, we will create a subnet service endpoint. So I'll go to VNet and I'll pick a virtual network that I have. Okay, I'll pick this VNet and I'll go to service endpoints and I'll click on add one service endpoint and I'll select Microsoft.storage. So I'll select all subnets. So service endpoint is added to this storage of this VNet. Now if I go back to my storage accounts, I have an option to limit the access to the storage account. So what I will do is I'll go here, firewalls and virtual networks. I'll say allow access from selected networks. Then I can specify my client IP address, then exceptions can be given. So I'll add an existing virtual network. There you go. Subnets, I'll select the subnet, add. So I'll save this one. Now if I go back to my blobs, see, I don't have access to this right now. If you click on check, it will say that verify the storage account, firewall and virtual network settings. So basically, even from my computer, I cannot explore what's happening. It's only applicable. It's only accessible from the virtual network that we added. Let's say I add my client IP here. I added my client IP. I come back here. Just need to hit on save. Now if I go to containers, files, I should be able to access it. But if I go back and remove my client IP, my access is gone. So I'm removing my client IP. Save, done, overview, containers, files. See, I lost my access. So this is how you secure your storage endpoint. Basically, if you set it to a single endpoint, a single subnet or a set of VNets, the VMs in those VNet will be able to access it. It cannot be accessed from the public internet.
So, that was a clip taken from one of the modules of our step-by-step training program on Azure Solution Architect certification, including exams AZ303 and AZ304. I would like to invite you for a free masterclass on how to kickstart your journey as Azure Solution Architect, right from learning basics like implementing storage account, virtual networking, and getting certified by using our step-by-step 12 weeks roadmap to go from complete beginner to a certified Azure Solution Architect. If you are interested, register for our free class by going on to k21academy.com/AZ30302. I highly recommend you to go through this free class to see what to expect in the exam, learn basics about Azure Solution Architect certification, and to get a demo on deploying Azure Container Instance. So please visit k21academy.com/AZ30302. Please click on the subscribe button so you don't miss out on our future videos. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.